All right, let's go over lesson or notes 1.1. So something is notes. Learning targets. After this lesson, you should be able to identify or find individuals and variables in a data set, then classify the variables as categorical or quantitative. Number 2, we will summarize the distribution or just a bunch of numbers of a variable with a frequency table, counting, or a relative frequency table. So what is statistics? Statistics is the art or science of collecting, describing, analyzing, data. It's my first time with this electronic pen, so hopefully it gets better, my penmanship. And making conclusions from data. You woke up at 7:30, you woke up at 7:20, the other day you woke up at 7:05, so you probably wake up around 7:15. What's a population? A population is an entire group of people or objects that you are trying to find information about. So if I said your household, the population in that household would be everybody in your house. Your mom, your dad, your brother, your sister, your cousin. Alright, so what is a sample? Sample is a smaller group selected from the population. I'm randomly going to pick one person in your household, and that might be your brother or your pet. What is an individual? An individual is a group, is a person, animal, or thing described in a set of data. So data is just a bunch of those numbers or lists, right? So the individuals in your home would be your mom, your dad, your brother, your sister, your cousin, your grandma, right? Variable is any attribute or characteristic that can take different values for different individuals. Let's try in an example. The advice columnist Ann Landers once asked her readers, if you had to do it all over again, would you have children? A few weeks later, her column headlined, 70% of parents say kids not worth it. Indeed, 70% of nearly 10,000 parents who wrote in said they would not have children if they could make the choice again. Do you believe that 70% of all parents forget having children? Whoa. So do I think so or not? No. I do not believe that 70% of all parents regret having children because, so in statistics, your answers are going to be complete sentences, and there has to be a reason. So because is a good math reason word. The parents who took time to write Ann Landers were probably mostly upset with their children. Their letters, or their responses, their letters were not a good representation of all parents since the most vocal parents don't represent the majority. So these parents who are more emotionally will want to respond. And does that mean they're everybody? No, they're not. So what is the variable in this example? We talked about how a variable is a characteristic of a group. Let's redefine that. A characteristic about a try that again. A characteristic or a category and we'll be talking about the word category next. That varies over a group, I'm going to abbreviate because I'm running out of space, group of individuals. Varies over a group of individuals. So what is categorical? Categorical, think of like words. Places an individual in one of several groups. I abbreviate because I'm running out of space, or categories. What is quantitative? Quantitative, quantity. How many hamburgers do you want? It's a number, so numerical values. Numerical values. And here, because you have numbers, then it makes sense to take the average. We'll talk about the average later. To take the average. So let's do an example of categorical versus quantitative. Data from a medical study contain values of many variables for each group who were subjects of the study. Which of the following are, we're just going to use C for categorical or Q for quantitative. Again, categorical, you should be thinking like your answer is going to be like, I don't know, I call it words. And then for quantitative, you should be thinking, for Q, thinking numerical. You're thinking numbers. That's an easy way to describe it. So gender, if I ask you for your gender, what would your responses be? Your responses are going to be either female or male. Is the answer going to be words or numbers? And they're going to be words, so it's going to be a categorical. How about age? If I ask you for your age, what would you give me? You might say you are 16, you're 18, you're 55. That is a number, so it's going to be quantitative. How about for your race? If I ask you for your race, your answer might be I am Asian, I'm Black, I'm Hispanic, I'm Latino, whatever it is. So that would be words, so that would be categorical. Go ahead and pause, and then try to fill out D, E, and F, and then press play when you're done. So are you a smoker? The answer would be yes or no. The answers for yes or no, are they words or are they numbers? They are words. So that would be categorical. Systolic, blood pressure. If you don't know what systolic means, just mean the big idea is what is your blood pressure. You take your blood pressure, here's your hint, millimeters or measurements of unit here. So those are going to be some kind of numbers. Your blood pressure is going to be 125 millimeters of mercury. So that would be a quantitative. Level of calcium in the blood. So this is say take their blood and take that sample and how much calcium is in there. That's going to be a number, right? You have 15, you have 6, you have 0. Those are all numbers, so that would be quantitative. All right, let's go down here. All right, so what is an individual? Just pause right now and then go ahead and fill that in. Do it from memory, and then you can also look above. Remember, a variable we had said as a characteristic or a category that varies over a group. That varies over a group of individuals. You might be asking, what is the individual? It's a person. Green. Uh-oh, what happened? Individual is a person, animal, or thing described. We already copied this down in a set of data. In a set of data. All right, so let's do this example here. Here you have something called a table. The table, this is your whole table, of several roller coasters that have opened since April 2014. This is called a superscript, and it'll tell you where the data comes from. I didn't have it, so here's the questions. Which of the following variables are categorical? So think of categorical. Think of the different categories by names. So let's use, what color did we use above before? Categories was purple, blue, blue. All right, so which of those have words? So I'm looking in the blue here, and type, because all of these here, the answers for this name of the roller coaster, Wildfire, has a wood type roller coaster. So the answer is, if I ask you what type of roller coaster is Wildfire, the answer is wood. I actually like wood roller coasters better. I don't know why. They're a little rickety. So type is one of those. Now height looks like it's numbers, and then look at design. Design, the answer is, well, what do I do on the helix? You have to sit down. Sit down is words, so that would be categorical. And then quantitative, our answers are numbers, so that would be height, speed, and duration. All of the answers for those roller coasters are numbers. So height, speed, and duration. All right, what's the next part? The next part from this list is, using the chart above, complete the two tasks. Circle the, sorry, I'm reading, I should circle the individuals and square the variables. So we just said that the individuals are the person, animal, or the things. So I'm going to use, let's use purple. Have we used purple yet? So let's go ahead and circle the individuals. The individuals are actually each roller coaster, right? These are the individuals. If I ask you, sign up for who's signing up to be the new roller coaster, these are my individuals. So these are the individuals. Now we are asked to square the variables. So the different types of variables are what's happening. So did you notice these are all the different types of variables? What makes a different roller coaster, different parts of a roller coaster? The different variables of a roller coaster is the types, heights, designs, how fast they go, how long it is. And did you guys notice on those, the individuals and the variables, where's the purple and green? They are on the outside of our table of values. They're on the sides. Okay? All right. So what is a distribution? What is a distribution? A distribution, the distribution of a variable tells us what values the variable takes and how often it takes these values. And so in our goals was to help you figure out a frequency table and a relative frequency. So let's go ahead and describe what a frequency table is. A frequency table shows the, okay, so I'm going to use count. I'm going to change the colors there so you can see the emphasis. Frequency is a table of, shows the count of individuals having each data value. And to emphasize count or frequency, you can just like count, right? How many, if you look at your desk, how many wires do you have on there? So if I look at I might have This is my tally marks, right? I have 2 of them. I'm just counting. Or how many keyboards do I have? I actually have 2 keyboards on my desk right now. All right, let's go to frequency table. A relative frequency table. A relative frequency table shows, all right, here's the big word, the proportion or percent. So if you're just doing this on regular paper, you can just go back and highlight it. That'd be a good idea. Of individuals having each data value. All right, here is an example. Which would you rather be? If you could pick only one of these, which would it be? Go ahead and check one of those, and then I think I'd rather just be, to me, happy. And if we got a data set, all right, so let's move on to page 3 here. Here's the data from 40 randomly selected high school students around the US. So here, each one of these are data. And this is how students respond. So I'm not sure how you responded. It says tally or count up for each status. What is that called? Look above. To count or tally. This would be our frequency table. Wow, so bad. Sorry. Again, first time using this pen. So this, then I'm going to highlight in blue. This is our frequency table. So when you tally or count, let's write the word count over here, or frequency. Okay, we're going to have to count how many famous people. I'll do one and then you do the rest, okay? Here is a practical thing when we're looking for the word famous. To tally, you might just mark them as you go, but I'm actually going to use my pencil and check each time I see the word famous. And the reason why you do this is so that you don't skip any of the data. You don't leave anybody out. So 1, 2, 3. Just going down 4, 5, 6, 7. So there were a count of 7 for those who were famous. Go ahead and just count up the rest and then go ahead and make a total of those. Go ahead and press pause, and then when you're done, press play. All right, so if you go ahead and do that, you'll get 21 rich, 4 healthy, 21 happy, 4 healthy, 80 rich, and then you have a total of 40. This sounds so silly. You're like, oh, if you did make a mistake, okay, this is something very practical in statistics, just counting. And like I said, use those check marks, and you should have a total of 40. All right, what happens when I now want to calculate a proportion or percent? Okay, let me write another word over here. Proportion or percent, you get those from fractions, right? This never goes away. Fractions. Okay. So this is called, when I turn in the numbers above to a fraction, this is called a relative frequency. Okay, so let me do this. Let's do a different color for the total. See if I can write in here. Again, new pen. Figuring this out, guys. Give me a break, okay? All right, so what we're going to do is basically make a fraction. So let me show you how to do that. So the total, I like to write my fractions this way, 40. That's the total, right? And then let's do famous. There are 7 out of 40. Okay, so there's my fraction. Some of you guys may have done something like this. I do not recommend the horizontal, so I prefer this one, the vertical versus the horizontal. This is perfectly okay. So now we got to make it a, we go from fractions to decimals. I have no calculator function here. So put in your calculator, 7 divided by 40. 7 divided by 40. And your answer is going to be 0.175. Okay, so how do we make this? Because this is, up here it doesn't say fraction, it doesn't say decimal, it says a percent or proportion. So now, so we go from fractions to decimals. And basically what you're doing to get a decimal is you are multiplying to get a percent. You are taking the decimal and you're multiplying it by 100. So you can put in your calculator times 100, don't touch your calculator. And what this does is you're moving the decimal place 2 places, and your answer is going to be 17.5%. So let's review really quickly. You take the number of famous and you put it over 40, and then you're doing division there, and you'll get a decimal. You should never have a number over 1 here. So this is like 17 cents, and then to go from a decimal to percent, you multiply by 100. Go ahead and finish the rich, healthy, and happy, and then press play to check your answer. All right, so here's my answers. Just trying to fit different colors so I can use it. The top parts of my fraction, the numerators, all of these numbers are adding up to be 40, right? Here's my decimals. If you add up all of those decimals together, think of money like change, 17.5 cents, 52 cents, 10 cents, 20 cents. You add them all up, they should be $1. So a decimal, most of the time, is never going to go over 1 in general. Probably about 95% of the time in this class. If you add up all the percents going down, they should add up to be 100%. So now it's time for your homework. Hopefully this is helpful for you. Good luck, guys.